Of all the terrifying and fascinating objects in the cosmos, none captures our curiosity and fear quite like a black hole. It's the ultimate point of no return, a cosmic vacuum cleaner in popular imagination. But what would actually happen if you brave and unfortunate astronaut took the plunge? The answer is a tale of two perspectives, a story where your experience and that of a distant observer diverge in the most extreme way physics will allow. First, let's set the stage. You are approaching a stellar mass black hole, the remnant of a collapsed giant star. Your initial approach might be surprisingly uneventful. There's no solid surface, no crust to crash into. You are simply following the curved path of space-time, a path that gets increasingly steep. Your goal is the event horizon, the invisible point of no return. Once you cross this boundary, not even light can escape. For a large black hole, crossing this threshold would be momentarily uneventful. You wouldn't even know you passed it. There's no flashing sign, no physical barrier. The real drama begins with tidal forces. As you fall feet first, gravity pulls much more strongly on your feet than your head. This difference in force, the tidal force, stretches you lengthwise. Simultaneously, your sides are compressed inward. You are being transformed into a stream of subatomic particles, a process aptly named spaghettification. For a small black hole, this happens far outside the event horizon, shredding you instantly. But for a supermassive black hole like the one at the center of our galaxy, the tidal forces are gentler. You could theoretically cross the event horizon intact, embarking on a one-way journey into the unknown. Now here is where physics becomes truly bizarre. Let's switch to the perspective of your friend on a safe spaceship watching through a powerful telescope. As you fall toward the event horizon, they would see something profoundly strange. The immense gravity causes a dramatic slowing of time, an effect called time dilation. Your signals, whether light waves or radio transmissions, would take longer and longer to climb out of the gravitational well. To your friend, you would appear to slow down, moving in ultra-slow motion. Your image would also grow progressively redder and dimmer as the light waves lose energy. You would never quite seem to reach the event horizon. Instead, you would fade to red, then to black, your final moment frozen in time from their perspective. They would never see you cross. But you experience something entirely different. From your point of view, time passes normally. You continue to fall, crossing the event horizon without a flicker. According to general relativity, once inside, all paths lead inward. The singularity, the point of infinite density at the black hole's center, is no longer a location in space, but a moment in your future. You are inevitably rushing toward it, just as you are inevitably rushing toward tomorrow. What happens at the singularity? Physics as we know it breaks down. Our equations of gravity become infinite, and we need a theory of quantum gravity, which we don't yet have to describe it. You would be crushed out of existence, your mass added to the black hole's total. So who is right? The friend who sees you frozen forever, or you who experiences a catastrophic end? Astonishingly, both are correct from their own frames of reference. This paradox highlights the deep incompatibility between Einstein's general relativity and quantum mechanics, one of the biggest unsolved problems in physics. Some theories, like the holographic principle, suggest that information about you might be encoded on the event horizon surface, a kind of cosmic fossil record, but your personal journey is irrevocably over. Ultimately, falling into a black hole is a one-way trip into the most extreme environment in the universe, a place where the very fabric of reality is torn apart. It's a journey that stretches you, slows your time to a standstill for onlookers, and ends in a place where our current laws of physics surrender. It is the ultimate adventure and the ultimate mystery, a reminder of how much we have yet to learn about the cosmos. If you enjoyed this dive into the depths of space-time, be sure to like and subscribe for more explorations of the universe's greatest wonders.